And with that, I'll introduce our first speaker. Doug Ernst is going to give us some of his perspectives on indoor shrimp farming and some of the production systems that he's used. And so these first few presentations are really a lot to do with engineering and some of the considerations associated with that. So thank you, Doug.
Thank you, Andrew. Okay. And thank the Ziegler team for inviting me to this, and they're hosting me and funding me, basically. And to you, Andrew, and your team, and your colleagues, and your stakeholders, you got a great program here. It's really national class, and it's so focused. To come together like this is special, because normally you're at a big aquaculture meeting, and you're just spread into every other engineering and species. So this is really great stuff. I'm going to talk about my experience growing shrimp. I've been in aquaculture for almost 40 years now. I've been in shrimp culture since 2005. I started with Biofloc systems. I've evolved to clear water. I'm not saying what's right or what's wrong. I'm just going to tell you what I've been doing for 15 years or whatever. And so we'll go ahead and get started. This is a slide I like to look at because it shows the potential market to you as basically specialty growers of shrimp in North America. I like to think of it in terms of the total market, in terms of 1.5 billion pounds a year, most of which is imported. You know all this. So you say, well, let's say just 5 people out of 100 are going to pay extra for their shrimp. They want to get a locally grown, known shrimp at the farmer's market or wherever, and they're going to say it's just 5% of that total. That's 75 million pounds of shrimp a year just in U.S. and Canada. That's a lot of shrimp. And as you'll see in this next slide, this is the history of U.S. farm shrimp production since 1988. This is data I got from Granville-Treese. And as you can see, it took a hit from Tara syndrome virus back in the late 90s, and then through SPF technologies and the development of better animals, it took off and hit a peak in 2004, 2005, but then fell off in 2010 to 20% of that value. And that was basically Gulf Coast farmers that are seasonal production competing with global imports, and they just got priced out. It was like the catfish farmers in Alabama. They couldn't afford to sell their product for the market price and make any money. And so now it's about that 3.5 to 4 million pounds a year, and maybe 5% of that is indoor. So as I'm telling you about this work I've been doing for a while, I also, big note of caution here. This is straight out of Global Aquaculture Advocate, 2016. There's been a ton of failures in indoor shrimp culture, intensive shrimp culture. I know of many more failures than successes. And it's just something that you want to work your way into it. Start small, build up, make sure your technology works. Now this will all get posted, so I'm going to go through some of these slides pretty quick, but you'll be able to see it again later. So I'm going to kind of walk through a design procedure. And you know, no big new stuff here, but it's iterative. You figure out, usually start at your production plan and your targets. How much shrimp do I want to produce? Then what kind of system is it going to take to produce those shrimp? Then you get down into your enterprise budget. You see if you're producing shrimp for less than you can sell them for, and then you might iterate back up to the top and work through that till you're really happy with that. Don't spend a dime until you're really happy with your plan. And the biggest decisions you make here are production intensity. So at harvest, how many animals do you want to have per cubic meter? How many individual shrimp per cubic meter? How many kilograms per cubic meter? However you want to say it. Big decision right there, as I'll get into. The other big one is how long do you want to use your water? You want to use it for 100 days? Do you want to use it for 300 days? There's a big difference on long-term things like nitrate accumulation that Ron Malone's going to talk about with denitrification. Now, so the first thing you're doing now is you're setting up, I don't know if those colors came through very well, but it's basically a shrimp survival, growth, and feeding program that, for example, if you're working with Ziegler Feeds, they're going to help you set up this program. And it's going to give you growth curves, feeding curves, survival curves, and you're going to get a production plan out of that. But even more importantly, you're going to get a design, a basis for facility design, because everything is based back on biomass, and really everything is based on feed loading. You end up designing your entire facility based on feed loading. And there's some targets down at the bottom there that I'd call those pretty strong targets, starting a PL10 and trying to hit a gram in 4 weeks. It's a pretty strong target, but to me, growth is the best way to measure performance because it integrates everything together. Bacteriology, water quality, everything is integrated into growth. You want to track growth very tightly. Here is a growth curve from, just like other animals, there's an exponential part, a linear part, and an asymptotic part. Shrimp have a really long linear part. They don't look like a trout, for example. Trout come over a little quicker, and that linear isn't so long. But once those animals get set up on that linear track, whether it's 1.5 grams a week or 2 or 2.5, it depends on genetics. Once they get on that line, if they fall off that growth curve, there's something wrong with your shrimp. So to me, I like to do weekly or at least every 2 weeks do weight sampling and keep up on that. The other thing that comes out of that feeding program is this basis for design, because everything, oxygen consumption and metabolite excretion, is all related to feed. And I, as an engineer, come in to design a shrimp farm. First thing I do, production plan. Second thing, what are your peak feed rates? Peak feed rates, and you can relate everything back to that. For example, ammonia production, you can relate back to the feed rate. For every 100 grams of feed going into the system, there's 3 grams of ammonia produced, which takes you straight into things like designing nitrifying bacteria production systems and denitrification systems. I am a proponent of starting new PL nurseries with new water. I don't like to reuse Biofloc water because of Vibrio, which I'll get into later. It's really quite easy to grow nitrifying bacteria in a like 1,000-gallon polyethylene tank. All you have to know is how much bacteria to grow. So you relate that back to what your feed app rate is, you get your ammonia loading rate, and then you grow nitrifying bacteria with ammonia chloride till they can process that ammonia chloride in 1 day, you're ready to go. And then as we get into systems, I think of it as a continuum of design, just like Dr. Ray would say, or everybody's been talking about. You can take your basic biofloc, add on some mixed bed bioreactors and some clarifiers, and then if you want to go all the way to clear water, there's kind of a break there, but basically that's an extension of a hybrid system. And in a biofloc system, these to me are what I would call the essential elements. I'm a big believer in probiotics. I'm a believer in growing your nitrifying bacteria and inoculating systems. So making new biofloc with symbiotics that I'm going to talk about and with nitrifiers. Doing a little flock cropping, and if you're using your water intensively, you might even have to be doing denitrification within the course of a 20 to 20 week grow out period. You might hit your nitrate limit and have to be dealing with that. This to me are some are optional, some are essential elements of a Biofloc tank. The first thing that I really highly try to get people to do is to enclose the water body with the air enclosure over the water and vapor seal it. Because typically where we are, most of your temperature control is heating, and your heat loss in a system like this, 85% of it is evaporative transfer. Second thing, why have all that humidity in your room where your people are working? Third thing, why have all that humidity in your room where your equipment is, your motors, etc.? And fourth, you still need a shrimp fence around that tank, or you're going to come in the morning and you're going to have a good number of them on the floor. So what I do is I build vapor seal enclosures that also act as the shrimp fence. And then I like automated feeding if you can handle it, because you can feed shrimp 24/7 every half hour. It spreads out your loading. Remember, everything's based on feed, so you spread out your feed, you spread out your loading. Aeration, of course. Water treatment and reuse, hydronic heating. Usually a drop-in titanium coil is what I use. And however you get heat to that coil, you can use waste heat, you can use solar heat, you can use a wood-fired stove, you know, but typically it would be like a gas-fired boiler, even a swimming pool heater. I've tried various gas exchange devices. So I started this in 2005, and nozzles were not on the scene, and honestly, we just didn't think of it. So we built diffuser pods, I call them, using Colorite porous hose. It's real cheap, and over here on the side you see it, it's just made out of like 3/4 inch PVC, or probably 1 inch, with those the little black parts are that porous tube. It's sort of like soaker hose you'd use in your garden. And you could pop those out, throw them in the washing machine, pop them back in. And that worked fine. But I've since learned that the nozzle technology is much superior for a few reasons. One reason is it shears the flock, because flock can get up to a 500,000 micron, you know, a whole millimeter. And that's too big for flock. You want to keep it fine so it's more active. Because when it gets real big, the bacteria in the middle of that particle, they can't get the food they want. If you have a nitrifier in the middle of a 1 millimeter particle, it's not getting enough oxygen and it's not getting the ammonia it needs to be really good. So shear the flock with a nozzle. You're also going to have a lot less maintenance, and you're going to have better gas exchange. This is a system that I was associated with NaturalShrimp. This all started in 2005. We started with greenhouse systems. You can see over on the side there are mixed bed bioreactors on that greenhouse system, and that was helpful because with greenhouse systems, you're going to get potentially algal cycling. And we actually had, this is San Antonio, Texas. So you go through these hot summers, fall would come along, and you get an algae crash, which can lead to a nitrite spike because it throws off the whole ecology of the system. We actually were not too enamored with greenhouses. They're so hot in the summer, and condensation messes in the winter with black mold growing. Even double layer greenhouses, kind of a pain to work with. So we moved to a barn type idea. That's a chicken barn technology out of Arkansas by Latco. It's pole barn, truss, 6-inch posts, outside's enameled steel, inside's just plastic, like fiber reinforced plastic, and then they blow in insulation into all the walls. But these are just typical Biofloc tanks that you're pretty familiar with by now. We used, so air enclosures, there's the door into the tank. We used YSI 5200, whoops. That YSI 5200 right there, we used it to control the hydronic heating loop. So you have one master loop, and then every tank has an exchanger with the pump. We also see we're using air diffusers, and we're pushing densities. So we also had some ceramic diffusers for pure oxygen. And then you can put, that 5200 is pretty handy for like a programmable PLC is basically what it is. And you can set up it to run your feeders, turn on oxygen, and run your heater. And then we did some external clarification, and we did some denitrification. And as I'm going to show you, everything went really well till it didn't. We had a partner facility. It was a joint venture facility outside of Madrid, Spain, with Bjorn Aspheim and Manuel Poulon. Here they went in ground. The ground was so hard there, they could cut these into the ground with I think it was a 30-degree side slope. So what you're seeing there is you're seeing the air enclosures over those tanks that are cut in that you can see on the side there into the ground. And those are like, those tanks are about 70, 80,000 gallons. Here's Florida Organic. I'm showing you a few like example large facilities. Florida Organic didn't make it. I'm not going to elaborate in front of you why, because I'm being filmed. But it wasn't a happy story, but maybe that'll get going again. An interesting thing they did here is they built their walls out of sandbags. So as you can see, that's a thick wall. They build up those sandbags walled and then high-density polyethylene liners. I think their water depth was about 4 feet. I think total tank depth was 5. Les Nosen, who came from Florida Organic, built a nice little system there in southern Florida. It's a small, tidy system, well run, and you can go visit him if you want. He's very open. You can go in and see how he's doing things. He's basically using Biofloc systems with nozzles and clarifiers. There's a clarifier. There's a tank. He's using de-ended raceways, which I think is a great way to go, because if you have nozzles, you can induce a horizontal current as well as that lifting of air that gives you your exchange. And then what really works is to put, if you can do it, is to put a sump pit at like the corner of your de-ended raceway. And as that water's going around, you will collect molts and morts. Because if you think of it, you got shrimp in there at anywhere from 200 to 500 per square meter. It's like having a janitorial force working for you. And they're always picking stuff up and throwing it over their shoulder. They're just little gluttonous feeders. They never stop. And so anything that's on the floor in a trout tank will just sit there. In a shrimp tank, it'll keep moving, and it'll move into this sump. And I've done things where I've built airlift pumps that pull that material out of that sump and deposit it into baskets, and then the shrimp can swim out. Because if you go in with a dip net and just take all the stuff out of that sump, it'll be full of really healthy, happy shrimp grazing on molts and morts, which seems to be their preferred food half the time. So I ran into some problems, though. So this is 2005. Everybody's saying in the research world, it seems 10 kilograms per cubic meter is a reasonable biomass density target. Well, that went great for about 12, 18 months, and performance started falling off. And I went hard into this. I became sort of a bacteriologist, more or less. Worked closely with University of Arizona and Don Leitner, and went through histopathology and PCR. I worked with Nichols State in Louisiana, went all the way down to the organism, matching the organism in the water to the offending organism in the animal, Vibrio parahemolyticus. Was just killing these shrimp. And I'm confused, because they're saying, look for the primary stressor. Vibrio are an opportunistic pathogen. They're only going to attack a stressed animal. But there's no stressors. We're doing great. Our water quality is excellent. We're feeding top-of-the-line Ziegler feeds. Everything's good. And then I started thinking about it. And the studies I'm reading are discontinuous. The U.S. Marine Shrimp Farming Program would be 4 months in a greenhouse, 8 months dry. They're effectively disinfecting their systems between every crop. We're trying to do continuous commercial production. That is apples and oranges, not comparable. And I realized that these Vibrio are evolving in the system and becoming virulent, and we're not addressing that. And my view of Vibrio is that they're a whole lot smarter than I am. They've been around for hundreds of millions of years. And first of all, they're non-excludable. They're going to be in your system. They're going to come in with every PL batch. You're going to get, by the time you've been running for a year or two, you'll probably have 10 species of Vibrio in your system. Secondly, they're dividing every 30 minutes, say, or even on a slow day every 60. Think how many generations that is. Think of the pressures of evolutionary biology. They're going to adapt to your system. Thirdly, half the time you don't even know they're there. They're just hanging out, chewing on inorganic and organic material. They're a benign bacteria. If you don't plate for them, you won't even know they're in there. But what they can do is they can switch their ecology and become virulent. And they can excrete protease and chitinase. Well, the very things the shrimp is made out of. And here's what I think they're doing. And this isn't scientifically validated. It's an opinion we can share, toss it around. I'm willing to hear competing opinions. But what I think they're doing is when the shrimp get up to a certain biomass density, the Vibrio can sense that food resource in the water column, and they change their behavior. They're evolved to always attack the food resource that gives them the highest reproduction rate. So I'm saying that animal doesn't have to be pre-stressed. If you push your densities too high, you're going to get Vibrio switching on you. And here's the really amazing part. They can switch as an entire population. I'm talking, I've had shrimp tanks on the order of 75,000 gallons, Olympic-sized swimming pool, perfectly moving along, say 500 per cubic meter at 12 grams, and you come in one day and all of a sudden there's 10% mortality. And it just flips. And what can happen, so according to my hypothesis, is these shrimp are sensing that food resource, and then they use this thing called quorum sensing, and they communicate with each other with chemicals. And so all the Vibrio in that entire tank can switch as a population to this new food resource. And that's really, I would say, the core of my talk, is respect Vibrio and watch it in terms of your biomass densities and some other tools. And one of those, so I'm going to go through like the big 3 things I see as failure points. Aeration. I think this is easily solvable. The nitrogen cycle. I think that's also easily solvable. Once you understand it and you realize that you have to condition nitrifying bacteria to eat that ammonia, you're good to go. I would also say that at some time in the development of this industry, people would add excessive carbon to these systems, because if you put enough carbon in, the substrate becomes nitrogen poor, and the heterotrophs that are eating the carbon will go, man, I need some nitrogen. So they'll grab ammonia out of the water column and incorporate it into their protein biomass. That sounds really great, right? Gee, I can just throw some sugar in and take care of my ammonia. But now you got this huge biofloc spike with all the related oxygen loading. And I would avoid that kind of technology. Keep your biofloc low. Don't use carbon. Take care of your nitrifiers. But the hardest part of all of these is basically managing Vibrio. And here's another point that we can maybe discuss, and that is that it seems to me that the max shrimp density in a biofloc system to keep Vibrio from saying, I'd rather eat shrimp than shrimp poop, is around 5 to 6 kilograms per cubic meter. Now, I would like to come back here in a couple years and have this workshop be more focused on you farmers and what targets you're hitting. on your biomass densities. And remember, this is the first thing in your production plan. Your biomass density is going to be your economic bottom line. And you got to get production per area. You've got this barn here all full of tanks, and you've got all this fixed and variable costs. You got to get that production per area, or you're not going to make money off your product. So the very first thing you're doing in your production plan is you're deciding on a biomass density. And genetics come in here, really important. I've been using Shrimp Improvement System, PL, since 2005, basically. I think there are better genetics for resisting Vibrio, and I think you heard from a key individual on that yesterday. So I think you're all tuned up on probiotics. I like the shotgun approach to probiotics because basically Vibrio are so adaptable. If you just throw one probiotic in there, they can evolve around that faster than they can evolve through a handful of probiotics. That's, you know, again, I don't have hard science to say that, but it just makes sense to me. Any tool you use to control Vibrio, it'll evolve around it. And they're very, very adaptable. So for a while there, I was growing bacteria in fermentative reactors. I used to make beer. It's not nearly as hard as that. You could do it yourself. And I'm going to show you something really interesting here that's kind of new on the scene, and it goes by the name of Symbiotics. And it's basically you take some sort of carbon source and grind it up into a particulate size, inoculate it with your probiotics, and either fermentate it 5 minutes. Bummer. Anyway, I'm going to go, so I make this stuff up and I add it to my nurseries. So I'm adding nitrifying bacteria to nurseries, and I'm adding this magic soup. It's not magic, it's just it's particulate carbon, not sugar, particulate carbon plus probiotics. Either aerate it or ferment it for 24 hours, add it to your nurseries. It's catching on, and it's making a big difference in the last, I don't know, 5 years. It's kind of this new thing that people are doing. But here's some comparative numbers. This is in Sinaloa, Mexico. They went from 2 to 4 kilograms per cubic meter by the addition of probiotics through this mechanism. Here's one in Korea. These are very similar to what you're doing. So to me, it was of high interest because it makes your biofloc systems more powerful. But back to my experience, at some point I decided to try clear water. I think I better go a little quicker here. I went ahead and gave it a try. I had some boneyard stuff, and away I went. What's that? And then here's some shrimp sitting on a habitat. These is just standard technology, clear water, I'd call it. And they, what happens in clear water in a black liner is they come out sort of bluish because they're trying to blend in with the black liner. And Planet Shrimp isn't really too far from here. It's southern Ontario, just on the north side of Lake Erie. It's in an old, believe it or not, that was a giant tobacco facility. Huge warehouses, 65,000 square feet. And there we're using a full RAS technology, the same you'd use, say, for a land-based salmon system. It's a tank stack. It's layered raceways. That's about 325 feet long and 30 feet high. There's 6 layers in there. The water's 20 centimeters deep. And, you know, I'm not trying to say it has to be a stacked clear water system. I'm just showing you an example of something that's happening here. Those are the tank corridors. Those are the shrimp in the water. We're working on machine vision to count the shrimp and to measure their length and then relate the length to weight, and so be able to track populations and mean weight without touching the animals. And then harvesting started in June of this year. There's a chill kill. So they come out of the tanks and they go down a slide and they go into this, I call it the car wash. It's like a chill kill, but it's flowing water. It's what they use in like the poultry industry. So it's not like batch management through chill kill. They're on a belt going through a very cold car wash. And then they go through a grater. And then they go through a flash freezer, liquid nitrogen, and individual quick frozen. And everything's going out frozen heads on. And the interesting there is they tried taste tests, and frozen shrimp beat fresh shrimp. Now, I come from the fresh, never frozen school, but the bummer with shrimp is a really healthy, good shrimp on ice, chill killed perfectly, you know, basically after 48, 72 hours, that whole upper body is turning black to orange. And it just doesn't look good on the display case at the shrimp counter. So then the people are having to dehead them. Because it's great to, they taste better if you cook them with the head on. It's 35% of the weight of the animal. Sell the head. And then also there's a lot less HACCP. If you don't touch the animal and all you do is put it on ice, it's easier to get it out the door. And frozen is a consideration, I think. And the chefs love it because they can keep a stash of that in their restaurant, and they're not dealing with a perishable product. So thank you very much. I hope I didn't go over too much. Okay, all right.